Boric acid, Wikipedia article audio. Boric acid, also called hydrogen borate, boracic acid, orthoboric acid, and acidum boricum, is a weak, monobasic Lewis acid of boron, which is often used as an antiseptic, insecticide, flame retardant, neutron absorber, or precursor to other chemical compounds. It has the chemical formula H3BO33, and exists in the form of colorless crystals or a white powder that dissolves in water. When occurring as a mineral, it is called sassolite. Boric acid, or sassolite, is found mainly in its free state in some volcanic districts, for example, in the Italian region of Tuscany, the Lipari Islands and the U.S. state of Nevada. In these volcanic settings it issues, mixed with steam, from fissures in the ground. It is also found as a constituent of many naturally occurring minerals borax, boracite, ulexite, and colemanite. Boric acid and its salts are found in seawater. It is also found in plants, including almost all fruits. Occurrence. Preparation. Boric acid was first prepared by Wilhelm Homburg from borax, by the action of mineral acids, and was given the name sal sedativum amergi. However, borates, including boric acid, have been used since the time of the ancient Greeks for cleaning, preserving food, and other activities. Boric acid may be prepared by reacting borax with a mineral acid, such as hydrochloric acid. It is also formed as a byproduct of hydrolysis of boron trihalides and diborane. Boric acid is soluble in boiling water. When heated above 170 degrees Celsius, it dehydrates, forming metaboric acid. Metaboric acid is a white, cubic crystalline solid and is only slightly soluble in water. Metaboric acid melts at about 236 degrees Celsius, and when heated above about 300 degrees Celsius further dehydrates, forming tetraboric acid, also called pyroboric acid. Properties. The term boric acid may sometimes refer to any of these compounds. Further heating leads to boron trioxide. There are conflicting interpretations for the origin of the acidity of aqueous boric acid solutions. Raman spectroscopy of strongly alkaline solutions has shown the presence of B4 ion, leading some to conclude that the acidity is exclusively due to the abstraction of O from water. Reactions. Or more properly expressed in the aqueous solution. This may be characterized as Lewis acidity of boron toward O, rather than as Bronsted acidity. However, other sources say that boric acid is also a tribacic Bronsted acid, with successive ionization steps and acidities as follows. Molecular and crystal structure. Since the value of Ka1 is comparable to that of the reaction with O, the concentrations of Bo2 and B4 are similar. Toxicology. Polyborate anions are formed at pH 710 if the boron concentration is higher than about 0.025 mol/L. The best known of these is the tetraborate ion, found in the mineral borax. Uses. Boric acid makes an important contribution to the absorption of low-frequency sound in seawater. With polyols such as glycerol and mannitol, the acidity of the solution is increased. With mannitol, for example, the pK decreases to 5.15. This is due to the formation of a chelate, 4C6H8022B, and this feature is used in analytical chemistry. Industrial. Boric acid dissolves in anhydrous sulfuric acid. Boric acid reacts with alcohols to form borate esters, B3 where R is alkyl or aryl. A dehydrating agent, such as concentrated sulfuric acid, is typically added. The three oxygen atoms form a trigonal planar geometry around the boron. The BO bond length is 136 pm and the OH is 97 pm. The molecular point group is C3H. Crystalline boric acid consists of layers of B3 molecules held together by hydrogen bonds of length 272 pm. The distance between two adjacent layers is 318 pm. Based on mammalian median lethal dose rating of 2660 mg/kg body mass, boric acid is only poisonous if taken internally or inhaled in large quantities. The 14th edition of the Merck Index indicates that the LD50 of boric acid is 5.14 g/kg for oral dosages given to rats, and that 5 to 20 g/kg has produced death in adult humans. For comparison's sake, the LD50 of salt is reported to be 3.75 g/kg in rats according to the Merck Index. According to the Agency for Toxic Substances and Disease Registry, the minimal lethal dose of ingested boron was reported to be 2-3 g in infants, 5-6 g in children, and 15-20 g in adults. However, a review of 784 human poisonings with boric acid reported no fatalities, with 88% of cases being asymptomatic. Medical. Long-term exposure to boric acid may be of more concern, causing kidney damage and eventually kidney failure. Although it does not appear to be carcinogenic, studies in dogs have reported testicular atrophy after exposure to 32 mg/kg BW/day for 90 days. This level is far lower than the LD50. Insecticidal. According to the boric acid Euclid dataset published by the European Commission, boric acid in high doses shows significant developmental toxicity and teratogenicity in rabbit, rat, and mouse fetuses as well as cardiovascular defects, skeletal variations, and mild kidney lesions. As a consequence, in the 30th ADP to EU Directive 67/548/EEC of August 2008, the European Commission decided to amend its classification as reprotoxic Category 2, and to apply the risk phrases R60 and R61. At a 2010 European Diagnostics Manufacturing Association meeting, several new additions to the substance of very high concern candidate list in relation to the registration, evaluation, authorization, and restriction of chemicals regulations 2007 were discussed. Following the registration and review completed as part of REACH, the classification of boric acid Ca 100335-3/111113-50-1 is listed from December 1, 2010 as H360FD. The primary industrial use of boric acid is in the manufacture of monofilament fiberglass, usually referred to as textile fiberglass. Textile fiberglass is used to reinforce plastics in applications that range from boats, to industrial piping to computer circuit boards. In the jewelry industry, boric acid is often used in combination with denatured alcohol to reduce surface oxidation and fire scale from forming on metals during annealing and soldering operations. Preservation. pH buffer. Lubrication. Nuclear power. Boric acid is used in the production of the glass in LCD flat panel displays. In electroplating, boric acid is used as part of some proprietary formulas. One such known formula calls for about a 1 to 10 ratio of H3BO, 3 to NiSO, 4, a very small portion of sodium lauryl sulfate and a small portion of H2SO, 4. Boric acid, mixed with borax at the weight ratio of 4:5, is highly soluble in water, though they are not so soluble separately. The solution is used for fire-retarding agent of wood by impregnation. It is also used in the manufacturing of ramming mass, a fine silica-containing powder used for producing induction furnace linings and ceramics. Boric acid is one of the most commonly used substances that can neutralize active hydrofluoric acid. It works by forcing the free F anions into complex salts. This process defeats the extreme toxicity of hydrofluoric acid, particularly its ability to sequester ionic calcium from blood serum, which can lead to cardiac arrest and bone decomposition. Such an event can occur from just minor skin contact with HF. Boric acid is added to borax for use as welding flux by blacksmiths. Boric acid, in combination with silicone oil, is used to manufacture silly putty. Pyrotechnics. Boric acid may be used in Marcellus Shale hydraulic fracturing in Pennsylvania. Boric acid can be used as an antiseptic for minor burns or cuts and is sometimes used in salves and dressings, such as boracic lint. Boric acid is applied in a very dilute solution as an eye wash. Dilute boric acid can be used as a vaginal douche to treat bacterial vaginosis due to excessive alkalinity, as well as candidiasis due to non-albicans candida. As an antibacterial compound, boric acid can also be used as an acne treatment. It is also used as prevention of athlete's foot, by inserting powder in the socks or stockings, and in alcohol solution can be used to treat some kinds of otitis externa in both humans and animals. The preservative in urine sample bottles in the UK is boric acid. Boric acid solutions used as an eye wash or on abraded skin are known to be toxic, particularly to infants, especially after repeated use. This is because of its slow elimination rate. Agriculture. Recreational. Boric acid was first registered in the U.S. as an insecticide in 1948 for control of cockroaches, termites, fire ants, fleas, silverfish, and many other insects. The product is generally considered to be safe to use in household kitchens to control cockroaches and ants. It acts as a stomach poison affecting the insect's metabolism, and the dry powder is abrasive to the insect's exoskeletons. Boric acid also has the reputation as the gift that keeps on killing, in that roaches that cross over lightly dusted areas do not die immediately, but that the effect is like shards of glass cutting them apart. This often allows a roach to go back to the nest where it soon dies. Cockroaches, being cannibalistic, eat others killed by contact or consumption of boric acid, consuming the powder trapped in the dead roach and killing them, too. In combination with its use as an insecticide, boric acid also prevents and destroys existing wet and dry rot in timbers. It can be used in combination with an ethylene glycol carrier to treat external wood against fungal and insect attack. It is possible to buy borate-impregnated rods for insertion into wood via drill holes where dampness and moisture is known to collect and sit. It is available in a gel form and injectable paste form for treating rot-affected wood without the need to replace the timber. Concentrates of borate-based treatments can be used to prevent slime, mycelium, and algae growth, even in marine environments. Boric acid is added to salt in the curing of cattle hides, calf skins, and sheep skins. This helps to control bacterial development, and helps to control insects. Boric acid in equilibrium with its conjugate base the borate ion is widely used as a primary or adjunct pH buffer system in swimming pools. Boric acid is a weak acid, with pKa of 9.24 in pure water at 25 degrees Celsius. But apparent pKa is substantially lower in swimming pool or ocean waters because of interactions with various other molecules in solution. It will be around 9.0 in a salt water pool. No matter which form of soluble boron is added, within the acceptable range of pH and boron concentration for swimming pools, boric acid is the predominant form in aqueous solution, as shown in the accompanying figure. The boric acid, borate system can be useful as a primary buffer system in pools with saltwater chlorine generators that tend to show upward drift in pH from a working range of pH 7.5 to 8.2. Buffer capacity is greater against rising pH, as illustrated in the accompanying graph. The use of boric acid in this concentration range does not allow any reduction in free HOCl concentration needed for pool sanitation, but it may add marginally to the photoprotective effects of cyanuric acid and confer other benefits through anti-corrosive activity or perceived water softness, depending on overall pool solute composition. Colloidal suspensions of nanoparticles of boric acid dissolved in petroleum or vegetable oil can form a remarkable lubricant on ceramic or metal surfaces with a coefficient of sliding friction that decreases with increasing pressure to a value ranging from 0.10 to 0.02. Self-lubricating H3BO3 films result from a spontaneous chemical reaction between water molecules and B2O3 coatings in a humid environment. In bulk scale, an inverse relationship exists between friction coefficient and Hertzian contact pressure induced by applied load. Boric acid is used to lubricate carom and Navus boards, allowing for faster play. Boric acid is used in some nuclear power plants as a neutron poison. The boron in boric acid reduces the probability of thermal fission by absorbing some thermal neutrons. Fission chain reactions are generally driven by the probability that free neutrons will result in fission and is determined by the material and geometric properties of the reactor. Natural boron consists of approximately 20% boron-10 and 80% boron-11 isotopes. Boron-10 has a high cross-section for absorption of low-energy neutrons. By increasing boric acid concentration in the reactor coolant, the probability that a neutron will cause fission is reduced. Changes in boric acid concentration can effectively regulate the rate of fission taking place in the reactor. Boric acid is used only in pressurized water reactors, whereas boiling water reactors employ control rod pattern and coolant flow for power control. BWRs use an aqueous solution of boric acid and borax or sodium pentaborate for an emergency shutdown system. Boric acid may be dissolved in spent fuel pools used to store spent fuel elements. The concentration is high enough to keep neutron multiplication at a minimum. Boric acid was dumped over Reactor 4 of the Chernobyl nuclear power plant after its meltdown to prevent another reaction from occurring. Boron is used in pyrotechnics to prevent the amide-forming reaction between aluminum and nitrates. A small amount of boric acid is added to the composition to neutralize alkaline amides that can react with the aluminum. Boric acid can be used as a colorant to make fire green. For example, when dissolved in methanol, it is popularly used by fire jugglers and fire spinners to create a deep green flame. Boric acid is used to treat or prevent boron deficiencies in plants. It is also used in preservation of grains such as rice and wheat. For the game of carom, boric acid is sprinkled onto the board of play to act as a dry lubricant to increase the speed of the pieces when struck.